Hello friends, and welcome to the webinar on concrete modeling and detailing with Tekla Structures software. I am Sunil Lidkar, Business Account Manager, and with me I have Sharad Kadam, Technical Specialist for today's webinar. We all are aware about Tekla's capabilities for steel structures, mainly for 3D modeling and fabrication integration with BOM and various reports capabilities. Today we will show you the capabilities of Tekla software for engineering configuration, mainly for engineering companies and EPC companies. We will see the software features and the capabilities for machine foundations, chimney, cooling towers, tanks, silos, etc. Since we need equal attention and serious attention for all these man hours and deliver drawings accurately, its quantity reports and most important undertaking any revision in the drawings. Further to this, we will show you the 3D modeling capabilities with reinforcement, how to extract rebar quantities, that is BBS in Excel format, how the automatic drawing will be generated, equally how it will be updated as well with respect to PDF output and Excel output. We will also show you the add-on tools which we have developed and which we have inbuilt into the new versions for concrete structures. Further, I will ask Sharad to take this forward. Sharad, over to you.
Thank you, Sunil. Today's topic for the webinar is exploring concrete modeling and detailing with Tekla Structures engineering configurations. To start with, a brief introduction of the company. Tekla Structure is owned by Trimble. Trimble is a $7 billion market cap company with presence in 141 countries with more than 1,800 patent products. We are mainly into surveying equipments, hand-holding equipments, then in agriculture sector. We are also into the transportation and logistics and heavy civil. We are also into the buildings, and Tekla Structure as a package, it's included into the buildings. So here are some of the snapshots. So we are into the hand-holding surveying equipments. Then we in the BIM sector we have Tekla Structures as well as Tekla Structure designers. Then in planning we have Vico. Then we also have PlanCal, Meridian, WinEst, as well as SketchUp in the Trimble profile. Then we have a dedicated technical services team present to support all the queries. We have over 1,000 customers which are using Tekla Structures. It's worldwide. Here's a brief introduction about the global network for Tekla Structures. We have offices in over 20 countries, customers in over 100 countries, and our head office, Tekla Structures head office is into Espoo, Finland, while the Trimble head office is in US. So here's a brief agenda for today's webinar. Here we'll be seeing concrete modeling, 3D reinforcement, dynamic modifications for both concrete as well as steel. We will also see exact rebar quantity estimations in BBS format, in Excel or drawing or notepad or PDF. Then we will also see typical industrial foundations, raft foundations, pile foundations, and some of the standards such as octagonal foundations or the circular foundations. We will see how easily modeling for the complicated structures such as tanks, water retaining structures, hoppers, chimneys or silos is done. We will also see add-on tools for quick concrete and rebar modeling. To start with Tekla Structures and BIM, Tekla Structures is has own technology platform. We can have multiple users working on the same model. We can have model sharing as well, wherein people sitting across locations can work on the same model. It's mainly into the BIM part. Tekla Structures is a model-based software wherein we can import architectural, MEP drawings, conceptual design, then we can create general arrangement drawings, shop drawings, fabrication drawings, drawings and reports for various quantities takeoff can also be done, and construction management tools are available for the same. Tekla Structures supports 34 major country standards and codes. All the codes such as BS code, Euro code, US code and IS codes are all supported in Tekla Structures. It's a model-based software, so the change management is very good. For any changes in the model, the reinforcements and drawings are automatically updated, schedules and reports are generated. If there are any changes in surfacing or embeds, the changes are also automatically done. Just to interrupt, if there is any questions or queries, you can type in and we will try to answer some of the queries at the end of this webinar. To start with the concrete modeling, Tekla Structures has got the parametric modeling wherein all these values can be changed. We also have the fixed modeling. If some profiles are fixed and which are not going to change, then we can use that as well. And if there are some profiles which are parametric in nature, so we can use the parametric profiles as well. It's an easy to model and handle complex structures. It is easy for simple structures such as beam, foundations and columns, etc., as well as complicated structures such as bridge, chimneys, silos. We will see it in next slides. So these are some of the snapshot of typical structures. So here's something which a variable thickness or variable levels. It can be easily modeled in Tekla Structures. This is an octagonal foundation with reinforcement, which can be, we have some macros for the same. Then we can also incorporate MEP drawings, MEP models, so as to check the clashes. If there is any clashes, we can take care in the modeling itself so that there should not be any problems at the actual site construction. We can also take up the quantity of form work from the model. Moving on next, we have an easy modification of object geometry. We have an option called direct modifications or direct manipulation, wherein we can just drag it and change the geometry of the objects or rebar. It modifies the geometry by dragging handles or edges or surfaces. Works for concrete beams, columns, panels, slabs and footings, and also for all the steel elements. Can be used to modify cuts or openings that are present in the structures. Just a small example of how a complex geometry can be handled. Here is a small example wherein a bridge deck is taken, and a second example which we will be taking is INS tank or an elevated water storage reservoir, we can say. We have taken a cross section of it. We will see how with the help of this AutoCAD file we can create a 3D model. So to start with, I've taken a bridge deck profile. So herein we have many options to create or to define our own profile, such as sketch editor, polygon, plate or DWG file. So the sketch editor is basically for parametric and rest all are for the fixed profiles. So herein we are using a DWG file. So here we can specify what the name we want to give. In this present case, we have taken the name as bridge. We can define any name as per our requirement. We can select the file, and with just 2 clicks, the profile is created. The profile that is created is a native Tekla profile. We can add reinforcement, we can cut it, we can do anything to it as the same thing the way we are doing it to the native Tekla profile. These profiles can be taken across the model or can be shared, can be taken in the new model as well. Similarly, we will see one more profile which is basically a tank profile, and now we will see actually it's already created. We will see how we can use it to create a tank profile. This is a cross section we have created in a circular manner, and the second half of it. So in this way, a circular tank or an INS tank or a water storage is created. We can split it into various pores as per our requirement or as per the constructions required, or as per the constructions requirement. We can do that. So just adding some clip planes to it so that we can see it clearly. So it's very easy to create these kind of profiles, and whatever we have shown here is not only applicable for a water tank or a bridge profile. This also applies for silos, bunker, chimneys, or any complicated structure wherein a profile is required. Moving on next about the reinforcement modeling. So we have three different approaches for reinforcement modeling. The first thing we prefer is the using of macros. We have a big library which caters to all the requirements with basic foundations, pad footing, column, beam, slabs, or any other structures. For starter bars, we can use these default macros that are available. We can create our own custom components. If something is missing from the library, we can create our own custom components. Here's few more components such as piles, octagonal foundation, radial bars, raft foundations. These are already there with the default installations. Then some more, these are again some different kinds of piles, circular foundations or octagonal foundations again, or a pile cap. These are there. The second method for adding rebar is with the rebar shape catalog. This is a dynamic way of modeling reinforcing bar wherein lengths are calculated automatically based on the geometry of the object. We don't have to pick the shape of the bar, then the range of the bar. It is automatically taken care by the shape catalog. So whatever frequently used bars are there, we can club it together and adjust rebar properties or group properties, spacing, bar diameter, etc. So again, herein we can customize this shape catalog. The frequently used shapes such as L bar or a straight bar or a U bar can be clubbed together and made as a favorites. The third option for rebar is the manual modeling of rebar, wherein we can model single rebars as per our requirement. We have various options such as normal rebar. Normal rebar is a rebar wherein we are just picking the shape and the range. Second option we have is the tapered, wherein the shape is varying as per the length of the member, can be used for tapering members. The third option we have is tapered ridge or tapered curve, where this shapes are self-explanatory. We also have the spirals, generally used for circular columns. We have an options for manual and automatic splicing. We can manually splice at whatever locations we want to, or we have a second option which is called as automatic splicing. Generally we have the maximum stock length. We can define this maximum stock length in this program. By default it is taken as 12 meter. We can customize it. It is basically a notepad file, so we can customize this file and use it as per our requirement. So if a bar is modeled for say 100 meter, we know it's practically not possible to take a 100 meter bar, so we can splice it in the 12 meter length or whatever default stock length we have. And this stock length can be changed as per our requirement, as per the grade, or as per the company standards. It's very easy to use tool. Then we also have the rebar meshes. Rebar meshes are mainly used in slabs, walls, or trenches. We have three types of rebar meshes. First one is the polygon, rectangle, and then the bent meshes. Polygon meshes are used for an odd shape geometry. Rectangle meshes are mainly used, they have got the fixed dimensions, so are used mainly in wall panels and slabs. And the bent meshes are mainly used into the trenches or any other irregular shapes. We have the options for cutting the meshes as per the openings, such as shown in this image, wherein if there is an opening we can cut it. There's an options, again we have an options to ignore the cuts. Suppose some of the cuts are smaller in length, say 100 mm by 100 mm, and we want the bars to pass through it and it will be cut on letters, so that option is also available. For continuing with the rebar products, we have cut and bend reinforcement, which are straight or bend bars. Then we have stirrups or the spiral stirrups, normal stirrups and spiral stirrups, which is mainly used for the circular columns. Then we have ties, hoops, and other shapes. Then we also have this meshes, which may be a standard meshes or non-standard meshes, custom meshes with or without opening. or we can have a bend meshes mainly into the trenches or slabs, or we can have cages, maybe standard or non-standard cages as per the requirement. In other elements, we can have breast or lattice girder, which is lattice girders are mainly used for precast elements, and for top portion is cast in place. We can also have couplers, other accessories which include coupler, connectors or anchoring members, spacers, form savers. All this can be modeled in Tekla Structures. Moving on with the rebar modeling. Rebar modeling is very easier, such as here we are seeing we are adding some starter bars to footing or footing. So with just one click the starter bars are added and it is fully customizable. Now we are taking a pad footing macro. We can modify as per our requirement and add the pad footing rebars to it. Say strip footing or the plinth beam, we can modify these main bars quantities and all, covers, spacings, etc. can be modified and done. So this maximizes your productivity. The second option that we have seen is the sub catalog, wherein we have to just pick the element and the rebars are added. It takes the shape from the object. We can modify the cover, spacing, how much bars we wanted, such as herein we are putting say 8-inch spacing, so we can modify it as per our requirement. So herein we want to shift the bars, we can do that, and it is done as and what we are seeing. Say we want to add an L-shaped bar, so that can be done. So in whatever directions we want to add it, we can do that. Similarly, moving on ahead, this is for column. So we can select the column macro, with or without laps and side bars, the quantity that is required, we can define it with bar dimensions and everything. So this reinforcement is added with a lap at the tops. We can also add side bars for slabs, which is basically edge bars. We can select it and just one click the side bars are added. Again, longitudinal bars for rebar, for beam. If we want to give some longitudinal rebars to the beam, we can do that. We can provide the hooks at the end as per our requirement and the length can be changed. It's fully customizable. We can also use the stirrup macro, which have 7 different zones for adding. Mainly we are using 3 to 5 different zones. We have then options for using 7 different zones. Then we have the mesh reinforcement macro, wherein we can select the macro and just one click. We can also provide edge bends at the ends as and when required. So with one click the reinforcement is added. So it's very simple, easy to add reinforcement, and this is completely adaptive. Means if we are changing the beam sizes or slab sizes, it can be changed. If there are some embeds which are added and it is conflicting with the rebar, we can ensure that it fits. So herein we can see that if it fits in model, it will definitely fit at site. We can also get the quantity of rebar that is used. Say for example, here we are getting 6 mm, 8 mm, 10 mm. How much quantity of rebar is used, we can, with just one click we can get it. This is through the organizer. Say for example, we are getting we want for second floor how much rebar is used. So in the right hand side we can see the rebar quantity. We can group it as per our requirement based on shape, size, diameter, or whatever options we want to. We can color it based on the groups. So herein we can see that all these are the straight bars that are selected, and all these things can be exported to Excel as well. So herein we want for say second floor beams, and we are just giving a different colors to it, and now we are exporting the quantity to Excel. So with just one click the rebars are exported in the Excel format. And this Excel format is also customizable, wherein you can group and ungroup the bars. So it's very easy to use, easy to handle, and the output that we are getting is very easy to be obtained. Again, we have some localized custom components such as the spile component, or we will see these components in detail in the next slides. We also have radial bars, hoop bars, which is useful for chimneys, bunkers, silos, water retaining structures, water tanks. So few more custom components, mainly cantilever beam. We also have stairs or slippers. So all one-way, two-way slabs, continuous column macros with staggered lapping. So all these options are available. We also have an octagonal footing, then isolated footings. So all these macros are available with the installations. So some more modeling tools that are more useful for these kind of industrial structures, such as creating an hollow section. This is useful for in case of chimneys, wherein we have we can also provide the thickness at various stages. If it is tapering at the top, we can define it here itself. So with this kind of tools, it is very useful and handy to create complex geometry. So this was basically for tapered hollow sections. And we have few more tools. This is mainly for rebar polar array. It is useful in circular tanks or any circular water retaining structures wherein rebars are needed to be added as shown in the figure. Then we also have slab curved bars, which are useful for circular slab. The rebars are added as in the image. Herein we can also add the stock length or how much laps we want. If we want say fixed amount of laps, we can provide it. If we want to use the stock length, we can provide that as well. There are many options available for this. So moving on the next, we also have the hoop bars. Hoop bars are mainly useful for chimneys or in the vertical members, or if there's a circular wall, we can use it in this. Then we also have the circular panel reinforcement, wherein we can use for vertical reinforcement. Again, we have the options for using stock length, or if we want to give the crank, we can provide the crank as well. In industrial foundation or industrial structures, embeds plays a major role. We have default embeds with the Tekla structures. Here are few of the examples which the default embeds that we have. Again, these embeds can be customized as per the requirement. We can change the thickness, length, width, or diameter of the bar. All these things are fully customizable. So here are some of the examples of the embeds that are available with the default installations. So these embeds can be used for the industrial foundations or any other industrial structures as well. Again, we have a big library in Tekla warehouse, wherein we can download few more embeds from that. So these are the embeds. Again, if you want a more number of bars, we can add that. If you want to change the length of the bar, thickness of the plate, all these things are fully customizable. So moving on next, this is for modeling of foundations for substructure. We have various kinds of pile structures that are available. All these pile locations can be moved, shifted as per the requirement. So just a brief snapshot of this industrial structures. We have a circular foundation, octagonal foundations. We will see this in detail in the next slide. So herein we can see these are the pile foundations. We can change the dimensions of the piles. We can change the dimensions of the footings, all the vertically as well as horizontally. Herein, if we want to change the vertical offset, all these things can be changed. Foundation depth, it can be varied as per the standards or as per the project requirements. We also have the options for changing all these dimensions. Here we have an octagonal footing, octagonal foundation. We can change the pedestal heights, foundation depth, octagon foundation width, pedestal width. All these things are fully customizable. It includes the rebar as well. So we don't have to first model the concrete and then rebar. It's there with the default. We can change the dimensions, bar diameter, spacing, and everything. We also have a circular foundations. It is fully customizable. We can change all these parameters that we can see here. We also have the rebar inbuilt to it. With changes in spacing, diameter can be done easily. So this is just a brief introduction of various kinds of foundations that are available with the default Tekla structure installation. We also have the normal isolated tapered footing, isolated footing, normal isolated tapered as well. We have the various options for using normal footings. Herein we can see a normal footing, pad footing, wherein we have options for changing primary bar, secondary bar. We have the options for giving these bars in the 3 different zones. We then again the laces bar are also available. Then starter bars for footing or for column are also available. Then we have isolated footing. Then there are various types of piles footing available. So it can be used as per the project requirement or company requirement. We have the pile reinforcement, macro number 76, wherein we can specify primary top bars, primary bottom bars, secondary top bars, secondary bottom bars. We can also specify the laser bars. If we want more bars at the pile location, this tool has the options for providing that as well. So all in all the industrial structure foundations can be taken care with the Tekla structures. This is then octagonal footing. So with this we can create nearly all the types of footings that we are using for industrial projects. So moving on next, here are some of the sample projects which are done in Tekla structures. This is mainly a complex composite structure which has been done by one of our client. So herein we can see that all the foundations and all the reinforcement has been done in Tekla structures. Even the top portion has been done in Tekla structures, and all this reinforcement has been modeled. So here are some of the examples of it, some of the silos example. Some snapshot for the raft foundations which has been done in Tekla structures with rebar. Similarly, some more project snapshot. So here is the upper beam and how it is modeled in Tekla structures. Some drawings for silos. So these are the silos drawings which are created from Tekla structures. Few more drawings. Moving on next, we also get instant and up-to-date bar bending schedule. For any changes in the model, bar bending schedule automatically gets updated, or we have to create it again, but it is instant and up-to-date. So here are some of the samples of bar bending schedule which we can obtain on drawing, as well as we can get it in the Excel format as per our requirement or as per the company's or project requirements. So here are some of the snapshots of the same. We also get the BBS as per SP34. We are also using shape code as per IS 2502. If some companies are using as per IS 2502, we have the option for IS 2502 as well. A small video of the same. Herein we can see that all these rebars are being modeled with or as per IS 2502. This is the rebar shape manager. We can see all this rebar is as per the codes that has been defined. So just a small drawing of it and the default output, how it will be obtained in the drawing. We will see this. So herein we can see this, all this shape code are by the default output. So herein we can see it is as per IS 2502. All these values A, B, C, D values are as per the codes that we are getting. It's very easy to get, and all these templates are with the default installations. Then moving on next, we have an automatic clash detection. In industrial foundation or the industrial projects, we use a lot of embeds. We have a lot of MEP drawings or MEP elements that are coming up. So it's very essential to have to know where the clashes are coming up, so that it can be taken care in the modeling aspects itself, so that there should be less or no delay on the actual site. So we have a clash check manager wherein we can check or identify clashes easily. This can be removed in the modeling stages itself, and it improves the site progress. It reduces the delays that happens because of these clashes. It also saves the material, and the decision can be taken in the stages of modeling itself. So we'll move ahead. So herein we can run the clash check for the complete model, or if we want some part of it to be checked, then we can do that as well. So we can zoom to the objects. Herein we can see that with just clicking on it, we have zoomed to that object, and we can see here that these two objects are clashing with each other. So now we can remove this clash. The decision can be taken in the modeling stages itself. In the clash check manager, we have various options to solve if it's a new clash, if it is written, or if it is deleted. So we have these many options to it. Then we have clash type it also, if it is inside, or if it is a clash, or if it is a complex clash. All these options are available. Then we can assign it, or we can fix it. There might be some clashes which needs to be ignored. We can ignore these kind of clashes also. There are some clashes which can be taken care in the site, so we can ignore these kind of clashes. Then we can also set the priority to whether it's a high priority clash and there will be effect on the site, so that can also be done here. So we can set the priority as low, medium, high. So with this way we can easily remove all these clashes in the modeling aspect as well. We can sort, we can do the sorting by as per our requirement, maybe column ID or object, whatever sorting order we want. We can add various options such as profile, component ID, and assembly ID. All these options can be added or removed from this report. This report can be exported as well for sharing purposes. Moving on to the drawing, we have an automated drawings wherein these drawings are created. These are no conflict, and the change management is powerful. If there is any changes in the model, then the changes in drawing is automatically done with clouds, so that it should be identified where the changes has been done. Seen here in this image on the right hand side, we can see that the inserts are placed and the column sizes, after changing, it will automatically change in the drawing here. So we are changing the sizes and it reflects back in the drawing. So again, we don't have to do it in drawing. But in a 2D platform, we have to do all these changes, stretch the dimensions. So, but in the 3D platform or in Tekla Structures, all these changes are taken care. These are some of the sample drawings that are coming up from the Tekla Structures. Some more snapshot of the same drawing part. Here is the column drawing with bar bending schedules, some typical foundations that we are seeing. These are the default options that we are getting. We can customize the label as per our requirement or as per the company standards. If we want to place a 3D or if you want more views, we can create it as per our requirement. Here are some of the more drawings for the same. Some circular foundations. Here are some of the customer cases or drawings or models received from the customers for the actual projects that they have done. Some of the iconic structures, herein we can see that some of the iconic structures which were built in Tekla Structures. Moving on, next we will see about the benefits that we get with the Tekla Structures. Now basically it's very easy to model concrete as well as rebar. Change management is very easy and efficient. Tekla Structure can produce the most detailed geometry and better quantity data from the solutions. Tekla concrete modeling is very easy. Rebar modeling is very simple. We can use macros, we can use manual rebar, or we can use rebar shape catalog. We can customize our own shapes. Suppose there are some shapes which are not there with the default one, we can create our customized shapes as well as per our requirement or as per the project requirements. It's an accurate object-based quantity takeoff is there, which helps in the production logistics. It also helps in fast data from Tekla structure to production. If we are using some CNC machines or some bar bending machines, we also have then options for Unitechnic output, or we also have then options for BVBS format, which can be taken out from Tekla structures. It's easy to work with simple. It's easier for complex as well as simple structures, simple normal footing, column, beam structures. It is easy to work, as well as we have also seen how a complex structures can be created with the help of profile. If we have a profile with in a 2D format, we can use that. We can also create a profile in Tekla structures as well. It's very easy and handy to use. In Tekla Structure Concrete model, interoperability with various third-party applications are available, such as analysis and design. We have interoperability with StatPro, eTabs, Tekla Structure Designer. It's a seamless connectivity with it. Then we also have in the interoperability with plant design applications, SP3D, PDS, PDMS models. So it's very easy and handy, because various agencies are working in various platforms, so it plays an important role. It supports all the major country standards and practices, all the codes as per IS, British code, Euro code, or American code. All the codes are supported. It's open and customizable, so we can create our own customer specific requirements. If there are some customer specific requirements such as custom components, templates and all, can be easily created, customized by the users. There's no need for any language, software language for the same. Tekla Structure is concrete. The bottom line here is Tekla Structure Concrete is very well suited, cost-effective solution for concrete industry. It's not only for simple structures, beam, column, footing, etc., but it's also useful for complicated structures. We can also add embeds, concrete, rebar, and we can also get drawings from MEP or any other agencies. So to sum it up, Tekla Structures Concrete It's a very cost-effective solution for the concrete industry. So moving on next, if you have any questions, you can just type in, we will answer it. You can type in your questions. We're taking some quick polls. So there's a poll on your screen. You can click on the options and press the submit button. Okay, thank you. There's one more. You can click on the answers. There's one more poll question here. Do you use automated process? Thank you. And last question. Do you use Tekla Structures? Do you feel Tekla Structure will help you in your work? Thank you. We have some questions. We will take them. We have one question whether Tekla Structure and TSD both are same or different. Yes, these are two different software. TSD is basically for analysis and Tekla Structure is a BIM software. There's one more question. Can I hear this at a later stage? Yes, all this recording will be placed on the Tekla website and you can listen to it at your time. There's one more question about the formwork quantities, how to arrive at the formwork quantity. You need to model the formwork. There are a lot of components available in Tekla warehouse as well, wherein you can which you can use and model the formwork for obtaining the formwork quantities. There's one more question about this rebar shape. Can we modify rebar shape directly in Tekla Structures? Yes, definitely you can modify this rebar shape. You can create your own shape codes or shape rules in Tekla Structures. So thank you for your time. Please mail us for any queries, any doubts. Thank you.